So this morning we have a 2009 Pontiac Torrent, and the complaint is unstable idle, reduced throttle response. It seems to be idling okay right now. I just drove it in the shop. Check engine light is on. Service TPMS has got nothing to do with it. So we're going to have us look at it with a network scan and see what kind of codes it's got. So I've worked on this vehicle before, so I'm loading the history. It should auto ID, being an 09. There we are. And let's do a network code scan, and it's a pre-scan. I suspect something to do with TPMS or TPS, throttle position correlation, mass airflow sensor circuit low frequency. I wonder if they had it disconnected or something. Throttle actuator control module, throttle actuator position performance, 1516 and 2101. Okay, so it saved a network scan. This 1779 is probably related to the throttle actuator. System disabled for the anti-locks, again because of the throttle. Airbag pressure and presence system. Tire pressure sensors. Low voltage. Alright, so we'll have a look at these fault codes and what potentially causes them. So this is the freeze frame data for the P0102 mass airflow sensor circuit low frequency. It says it passed twice and failed twice, and the distance since the first failure is 2,345 kilometers. So it was running when it set this code at 1171 RPM. I wonder if it has a run time here. No, it doesn't. Oh yes, 2 seconds. Interesting. I wonder if it was set by somebody unplugging the mass airflow sensor and starting it, because it was running for 2 seconds, so that would make sense. And I don't think it wasn't moving, no vehicle speed, so I think we're going to disregard this code. I know the customer was trying to do some diagnosis on this himself, so I think he just generated this code by unplugging the mass airflow sensor. Let's have a look at the other codes. So this P1516 code set at 1 minute and 27 seconds into the run time. It was sitting still running, so it wasn't moving, and it was basically at an idle. Intake air temperature was -2 and coolant temperature was 27 Celsius, so it was partially warm when this happened. TPS APP1 and APP2. APP1 is at 19 degrees and APP2 is at 10 degrees. That's interesting. Let's see what the criteria is for setting that 1516 code. So here it says the P1516 code sets if the two TPSs in the throttle body don't agree, and right now they are agreeing. It's sitting at 4%, it's idling. Condition has to occur for 0.18 seconds. Check for binding conditions of the throttle blade. There is a TSB on this, I believe. I'm going to check and see what that suggests. So as I said, there's a special policy coverage adjustment for this particular problem. It affects a lot of different vehicles. For 10 years or 120,000 miles, 192,000 kilometers. Well, being an 09, this thing's over 10 years old. So it's outside this policy adjustment. It has to do with changing the throttle body sensor kit and reflashing the ECM with the latest software. So we'll have a look at that as a possibility. We'll price that, compare that to the actual replacement of the whole throttle body assembly. I've already inspected the wiring going to the throttle body assembly. It looks good, and it's currently not doing it, which makes it an intermittent problem. More than likely the position sensor inside the throttle body is failing. So I'm going to set up the dual trace graphing multimeter to do a sweep of this throttle body motor. To qualify the wires here at the throttle body motor as well. I looked at them visually, they look okay, but I'm going to set up the graphing multimeter to have a look at this. So I'm going to connect the dual graphing multimeter to pin D and pin F at the throttle body controller. So that's purple and dark green wire and a known good ground, and we're going to have a look at the two signals as I go through a throttle sweep. So here's the connection here. I'm back pinning the top dark green wire and the bottom purple wire. Channel 1 is on the purple wire, channel 2 is on the green wire, and we're going to have a look at the waveform as I move the throttle body by accelerating the pedal up and down. At rest it's sitting at 1.6 volts here and 3.37 volts here, and I'm going to accelerate with the accelerator pedal now, and hopefully this will catch it. I'm going to step on the gas pedal slowly and release it. And again. And one more time. So that should have captured 3 throttle sweeps. Let's back it up and pause it. Well, that's as steady as I could. So there appear to be a mirror image of each other, as you can see, and it's working fine now, but likely the throttle position sensor is malfunctioning at times internally in this throttle body. I'm going to save this recording. Yep. I haven't set the date and time in here. I'm also going to wiggle the wires now while I'm monitoring it and see if I see any change. Tap on the sensor with a handle of a screwdriver, see if that makes a difference. No, it doesn't seem to affect it. I hate when things are intermittent like this. Oh well. So I'm looking at throttle actuator data in the scan tool, and I've built a custom data list with TPS 1 and 2 at the top, APP 1 and 2 on the second row, and TPS 1 and 2 agree, yes or no. And my understanding is if these two don't agree by a certain amount in a certain amount of time, then we get this 1516 code and the 2101 code. So let's try a sweep here. Key on, engine off. I'm depressing the throttle pedal repeatedly. So as you can see, it's working just fine right now. And again, I can't get it tacked up. Well, I'm going to discuss the repairs with the customer. Thought I'd do this one more time with the TPS 1 and 2 percentage and see if both of these agree with TPS 1 and 2 voltage, because that freeze frame data did not store the voltage. It actually stored the TPS calculated percentage. So I'll do another sweep here and we'll watch these two right here and see if they agree throughout the sweep. So you can see they agree pretty good. Let's go back and have a look at that freeze frame data that I saved. So here is the freeze frame data for the P1516, and there's the recorded TPS 1 and 2 percentages right here. So TPS 1's at 6% and TPS 2's at 21%. So that's what would set that code. Let's have a look at the other one as well. There were 2101, and see if it's got in that freeze frame data, if it has TPS 1 and 2 in there. Where is it? 2101 freeze frame data view. So we're concerned about TPS 1 and 2 percentage, because this list does not record. So here's TPS 1, let's drag it up there. And here's TPS 2, let's put it right below it. So 21 and 32 at that time when it set the 2101 code. So given these two freeze frames, I would strongly I have a strong suspicion of the integrity of that throttle position sensor. Now the question is, do we just change the sensor or do we change the entire throttle body? We'll have to price it. So here are several versions of the throttle body. A Napa Reman one, it lists for $253. Dorman lists for $353. So probably around the $210 to $220 mark. I can't get onto the website for the parts supplier I usually deal with. For some reason their site is down today. Must be maintenance or something. Let's check just the throttle body sensor. Well, that's kind of a no-brainer. The throttle position sensor lists for $253, just the sensor, whereas the throttle body assembly comes with the sensor. And let's see where there's stock. Well, that's not looking too good. Well, that stands to reason. No stock anywhere in any of the Napa dealers in what looks like across Canada, or at least as far as Winnipeg goes anyways. Oh well. So we have a new throttle body, or a remanufactured throttle body assembly. If you're interested, there's the Napa part number for this particular model. It does say that an idle relearn procedure must be performed with a scan tool when you're done installing this. Now, when you replace just the throttle position sensor assembly as per the TSB, it says you must reflash the PCM with the latest software. I did one once, but the vehicle had nearly 500,000 kilometers on it, and I tried not to do the relearn or the reflash. I did the relearn. It would not do it because it kept setting a fault code for idling too fast. So we're going to install this one and attempt to do the relearn, and if necessary, reflash the ECM with the latest software. So basically remove the air cleaner lid, disconnect the connector on the mass airflow sensor here, the EGR, the engine cover, disconnect the throttle body assembly. Now this one does not appear to have coolant flowing through it, so we have to remove these 4 fasteners, and the throttle body assembly should just come off. There is a coolant pipe here, but it doesn't go through it, it just radiates heat up against the bottom of the throttle body. Okay, so we'll pick up once I get the throttle body assembly off. So I've removed the 2 nuts that hold this pipe here, but I can't pull it off because it's retained to the intake manifold downstream here. So I'm going to try and remove the studs, and that way I'll be able to just slip the throttle body straight up. So I'm using a Ultra Pro stud extractor to remove the studs here. It will grip the stud and then be able to remove it. Let's try this one over here. Okay, we'll pick up when I get it. So the two lower studs are out. Now we'll take off the two upper bolts. And we should be able to just slip that straight up and out of there. So you can see there's an O-ring seal. There's a new seal on the new throttle body assembly. This one's not actually that badly carboned up. Looks pretty clean. So we'll clean up this mounting surface and we'll put it back. So there's the surface cleaned off. I stuffed a rag in there so nothing would go into the manifold. And here is the new throttle body assembly with dielectric grease on the O-ring seal. And we just got to drop it in place here. You can pull that pipe out a 1/4 of an inch, enough to get the bolts to go in. Okay, we're going to get all the studs started. I'm going to clean up the corrosion on these bolts before I put them in. So these upper bolts that go into the intake manifold are 89 inch-pounds and the lower nuts are 53 inch-pounds. It's reconnected. I'm not going to put the engine cover back on just yet. I'm just going to reconnect the air induction system so that we can attempt to do a relearn. See how that works out. So as I said, the upper bolts are 89 inch-pounds and the lower studs are 53 inch-pounds. Okay, so I've got the scanner connected to the vehicle, key is on. I'm going to go into engine, I'm going to go into the codes menu and make sure that there's no current codes. There shouldn't be. There isn't. And I believe this is going to be in module setup. Clear codes display, functional tests. Let's try module setup. I think it's in here. Idle relearn, idle learn reset. Let's see what it suggests. Engine must be off and key is on. That is what we have now. Please wait. Select reset or exit. Okay, where's, oh, reset over here. Test complete. Might have to cycle the key off. I'm going to turn the key off for a few seconds and then turn the key back on and look at data. So it's running again. Let's look at throttle data. TPS 1 and 2 agree, as it says. TPS voltage is 1.09 this time, and TPS 2 is 3.91. As I said, they're opposite each other. TPS 1 has a negative slope, starts out high and goes low. TPS 2 has a positive slope, starts out low and goes high. And of course it's controlling the idle speed correctly now. So we'll take this for a road test, make sure it runs okay, put the engine cover back on it, and we should be good to go. So I figured just for the record I would do a TPS sweep with the key on, engine off, like I did before. Seems to be working fine. Both TPSs agree. So we'll put the cover back on and go for a road test.